Hi, this is your third video boost. What I was thinking about tonight was that I wanted to kind of give you the big picture about how you make decisions when you're naming things. One thing I did want to bring up is the second problem on your worksheet is something like this. And it's very difficult to name, and it's ambiguous in the sense that when you number this, you can go 1, 3, 5, 1, 3, 5. You can do 3 different 1, 3, 5s. And what you're supposed to do in that instance is alphabetize, or number in order of the alphabet. Now, this is the group on there is something like a bromo, I think it's something like that. But it ends up with a bromo, and this ends up being number 1. But what's ambiguous to people is how to choose this group over this group, because one's a methyl ethyl and one's a dimethyl ethyl. But realize one thing you could do is use common names and use isopropyl for this and terse butyl for that. And if you did that, you would be able to put them in order. But I will tell you, my goal is not to give you very complicated problems. Well, they'll be complicated, but problems that lead to ambiguity where we would have to consult more, finer rules than the rules we're using. Or more detailed rules than we're using. Now, I put this problem up to kind of show you the decision-making process, okay? And basically, the first thing you always have to do is pick the chain, okay? And when you're picking the chain, the first thing you consider are the principal groups, or group. The principal group or groups is the group of highest priority, and right now, you only have 3 priorities. You have alcohols, which are higher priority than alkenes and alkynes, which are higher priority than alkyl chains, or just side chains. So when picking a chain, your first choice is to pick the chain with the principal group or groups. Your second choice is your second goal is to try to accommodate the double and triple bonds, and your third goal is to pick the longest chain. Okay, and then finally, if you have some sort of ambiguity regarding the longest chain, you pick the chain with the greatest number of substituents. Now, when we began a few days ago, we were working at this level, and then as we worked along Friday through Monday, we worked our way up in that direction. So that there was a method to what I was doing, but sometimes people lose the big picture in that. So how would I apply this? In this problem, which is not inordinately complicated, you'd want to pick the chain with the 2 alcohols in it. Now, there are actually numerous chains with the alcohols in it. So, for example, you could pick this chain along here, or you could pick this one, or you could pick this one, or you could pick this one. So there's a number of chains there. Which one do you pick? Well, you have to go to the second criterion, which is accommodating the double and triple bonds. That's more important than getting the longest chain, okay? So what I would pick in this case is the chain that goes straight across, or in left to right, or right to left, because that chain has both the principal chain and the second priority group, which is the alkenes. Okay, so I'm following this criterion. Okay, so what would my root name be here? My root name, using the nomenclature rules from 1979, which is the way your textbook is written. It is written in 1979 nomenclature, as are many textbooks. I would write that this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a none, diene, diol. Okay, now, nona, diene, the diene refers to the 2 double bonds, diol, which refers to the 2 alcohol groups. Now, as you will recollect, in 1979 nomenclature, you put the numbers for the first functional groups occurring in the name ahead of the name. So the numbers for the diene have to be first, okay, and then the numbers for the alcohol second, all right? Now, I have picked the principal chain. I wanted to talk briefly about numbering. All right, numbering follows a similar level of, or similar criteria. So numbering the chain, numbering the principal chain, how much time do I have left?
5 minutes.
Okay, principal groups, double and triple bonds come second, and then what you want to be concerned with are substituents, positions, and then finally alphabetizing or numbering, as this last case I showed you, numbering in alphabetical order. And I'm sorry, I write terribly on whiteboards. Now, this, what I'm referring to here, is a very succinct list of how you make the decisions in nomenclature that is given in the first appendix of Loudon. It is truly excellent. It is 2 pages long, it is very simple, and it is very easy to follow. So if you're not getting the big picture, go there and look at this. It's fantastic. And that's exactly what I've outlined here. So we picked the principal chain based on the principal groups, or the high priority groups. Principal groups are the same as high priority groups. Then my secondary decision in picking the chain was the double bond. Now in terms of numbering, the same ideas are used. What I want first is to have the lowest number for the alcohol. But as you'll discover here, if I number in this direction, I get 4, 5, 6. If I number in this direction, I get 4, 5, 6. So really, it doesn't matter how I number it. I'm going to get 4 and 6 for the alcohols. But my primary criterion would be to get those in the lowest position. So I would go 1, 2, 3, 4, 5, 6, 7, 8, 9. Or alternatively, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 2 choices there. They tie on the alcohols. It's 4, 6 either way I go. Then you would go to the next criterion, which is double bond or triple bond position. In this particular example, the double bond positions are the same in each direction. So the decision can't be made at that level. So then you have to go to substituent positions. And as I've been saying in class, a substituent is a substituent is a substituent. You don't rank substituents. These 2 substituents are considered to be equal in terms of their priority. Okay, but you want to get the lowest numbers for them. But you discover again in this very ambiguous example that the substituents are at the 4 and 6 positions also, and it doesn't matter which direction I go in. So then what are you forced to do? You're forced to go to the last bastion of decision making, which is naming them alphabetically. So if I name these side chains, I made them pretty simple. These are 1, 2, 3, 4. They're butyl chains. This one is a 1-bromo-butyl, and this one is a butyl. Okay, they're even both B names. Okay, that doesn't need parentheses, by the way. They're both B names. So what do I do now? It has tied at the level of the alcohol. It has tied at the level of the double bond. It has tied at the level of the substituent, but it did not tie at the level of alphabetizing, which it should not. Okay? If it does, it doesn't matter which way you name it. So in this case, what would come first in the name? I would number it so that the bromobutyl gets the lower number or receives the lowest number, because BR comes ahead of BU, and it's simply that. So I would number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is finishing it up here, this is a diene, right? This is a 2, 3, 4, 5, 6, 7. This is a 2, 7, 2, 7, nonadiene, 4, 6, dash 4, comma 6, dash diol. Notice I leave the E in because it's a consonant ending. Now if you're using 1993 nomenclature, you can move this number in here, all right? I'm going to write in this mode because that's the way your textbook is. Now, how would I put these names in? These names would go ahead of this. Which ones comes first? Well, they're put in alphabetical order. So this would be, I'm a little short on space here, so this would be a 4, 1 bromo, butyl. Hope this makes some sense. Here's my butyl, 6 butyl, 2,7 nonadiene 4,6 diol. So that's the end of this problem, and I'll see you in class tomorrow.